In this video, I'd like to talk about the math question of the day for February 20th, 2023. And with this problem, we need to find the equation of the line that passes through the points 2, 6 and 5, 3. So to answer a question like this, you do need to have a solid understanding of Algebra 1 and everything that comes before that. So at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have at least attempted the problem, we can start working on it together. And as always, if you have a suggestion for a future question of the day video, feel free to leave that as a comment. Now, when dealing with the equation of a line, we really just need 2 points. And we need to figure out how steep the line is, and we need to figure out where the line intersects the y-axis. So if I draw in a quick coordinate plane, we can get a visual of what's going on by plotting these points, but you certainly do not have to do this. So we need an x value of 2 and of 5, so I'll put in at least 5 tick marks. And we need a y value going up to 6 and a y value going down to -3. So let's plot 5 minus 3, so that will be right about here. And we'll plot 2, 6, which should be right about here. And we're finding the line that goes between them, so that line will look something like this. And again, we don't need to draw this picture. This will just help give us a visual. And we need to think about what the slope of this line is, so how steep it is. And as x is increasing, the slope is going down. So we should expect a negative slope here. And we should expect a y-intercept somewhere up here, some higher y value. And remember that when combining those concepts, the intercept, the y-intercept, and the slope, we can rewrite this in what is known as slope-intercept form, or y is equal to mx plus b, where m, the coefficient on x, this is the slope, this describes the steepness of the line, and we define slope as the rise divided by the run, or as the change in the y values, this Greek letter delta just means change in, divided by the change in the x values. So as the x values change, as we go over, how much did the y values change? Going down. So this change in y should be negative, and the change in x, we can define that to be positive. Now, this we can calculate in a couple different ways. We, first of all, could just think it through. The x values go from 2 to 5, so it looks like they changed 3 units. And again, we define this to be positive, so we wouldn't want to do it the other way. And we'll leave the negative on the y. If you do want to do it the other way, that's perfectly valid. It is arbitrary, but I tend to leave the negative on the y values if that's the case. So the x values were always going left to right, so 2 to 5 we are increasing. And then the y values go from 6 to -3, meaning they go down 9 units. So our slope, when we simplify this, is -3. It's fairly steep and it's negative, which does match up with our picture. Now, if we wanted, we could also use the formula. The change in the y values are just the difference in the y values of the 2 points, and the change in the x values, similarly, are just the difference in the x values of the 2 points. Where, let's say, this point up here is at x1, y1, and this one down here is at x2, y2. And when we actually plug in those values, you'll see we get the same result. y2 is -3, and we subtract 6 from that. x2 minus x1, we have 5 minus 2, so you get -9 over 3, which, like I mentioned, is exactly what we had. So you can use the formula, or you can just think it through. And we want to use this slope-intercept form, and I haven't mentioned b yet. B is just the y-intercept. It's the part of the equation when, if you set x equal to 0, this part just goes away and you get y is equal to b. Or it's the point that's actually on the y-axis, since this is when x is equal to 0. So we have most of our information. Let's just scroll down a bit so we have a little bit more room. We have y is -3x plus b, since we don't know what b is. But we can use one of these points to actually figure it out. Let's plug in one of them. Let's just say we're going to plug in this point, 2 comma 6. So we set y equal to 6 and x equal to 2. And we can find b from there. So this would be 6 is equal to minus 6 plus b. We add 6 to the other side. So that b is 12. And that makes sense, because if we go back up to our equation, you can see that this would intersect at a y value around 12 there, just based off this loose drawing. So we found b is positive 12, meaning that we can plug everything into our equation to find that y is minus 3x plus 12. And there are a couple ways to check this. The main one is that if you plug both of these points into the equation, you get back something that's true. If you plug in 2, you get minus 6 plus 12, which is 6. If you plug in 5, we get minus 15 plus 12, which is negative 3. So we check this, it makes sense, which means we can feel confident that this is the equation of the line. And if you didn't want to use slope-intercept form, you can also use what's known as point-slope form. It's actually derived from this equation right here. Just we set y2 and x2 equal to y and x. We assume that we only know one point rather than two, and we leave the other point general. And from there we get this equation where if you know the slope in one of these points, you can just plug it in and you will find that exact same answer.